Oh, sorry. Okay. Next one we're doing is extended ACLs. Done standard. Extended also does named and numbered ACLs. So we'll have a quick look at those, and then we'll play with the named ones. Primarily the reason for that is under IP version 6, you only have extended and named ACLs. So I think it's the best way to work anyway. Okay, so conft. Actually, we're just back onto router 3 in our network here. We're not going to play with these ones. Extended ACLs, put them as close to the source as possible, and run everything from there. So again, I'm not going through and getting the whole thing up and running. We're just going to go through the process of actually configuring them, making sure that we know how to configure them. Might come up with something a bit different later on. Okay, so we'll use the numbered option first and create an ACL for that. Pretty much the same kind of system that we had before in getting it running, but now extended ACLs gives us quite a lot more features in terms of different protocols to actually play with. So access list, and if you remember, put a question mark in there. Standard ACLs go from 1 to 99 and also 1300 to 1999. Extended ACLs 100 to 199 and also from 2000 to 2699. So let's create an access list number 100, and as soon as we type that in, the system knows that we're using an extended option, and we'll go through. So let's permit, and here it gets kind of chunky. Do we want to permit EIGRP, ESP, GRE tunnels, ICMP, IP, OSPF, TCP, UDP? Oops. These are just the options in Packet Tracer, and you'll have far more options in actual physical layer 3 devices. So layer 3 switches can run ACLs, and we're using it on a layer 3 device called a router, so that's what we're using them for here at the moment. So this is now quite a lot of information for us. So our access list 100, we're going to permit, let's permit UDP, and we're going to say the source host. So now not only do we have all these extra protocols, but we will have source and destination options as well. So let's go for host, and we put our source address, so 192.168.20.10, and what do we want to do? So more options available. The destination address, the any destination host. We can now actually put equivalents to actually look at the port that we want to play with as well. A destination host, we can go greater than, less than, we can look at ranges of port numbers. So let's just go equivalent 53. So what we're saying is, with UDP, we're actually playing with DNS. So port 53 is DNS on UDP. Actually, if UDP doesn't work, it'll switch back to TCP, but that's okay at the moment. So which destination host do we want to play with? So we could put any, or we can put a range of addresses. Now across this whole network here, we have 192.168.20 down here, 192.168.30, 192.168.10. I want all those addresses to be included as a destination. So let's put in 192.168.0.0 as our primary filter, and the wildcard mask that we're going to put in 0.0 and 255.255. So what we're saying is we're going to match 192.168 only, because that's the wildcard mask is inverted into that, and we can either hit enter there or do an equivalence less than whatever ports we want to play with as well. So there is hours of fun to be played with in this, and hours of ripping your hair out and trying to get these things working. So a lot of access lists is actually planning everything at the start. So in this case, with extended ACLs, I've said this is my source, so that host number on port 53, and my destination is going to be anything that starts with 192.168, and I don't care what port the destination is on. So I'm not too sure where you'd add this ACL. Our 192.168.20.10 host actually has DNS running on it, but we've got it run the wrong way. It's actually oh no, the source will be right. It should work actually. Yeah, let's have a look. So let's apply that to an interface. So conft, good one. So interface gigabit 00, IP access group, same deal we did with standard ones. What do we want? We want 100 to be applied inbound. Let's see if it works. Now if it doesn't work, we need to negate it. So let's just check something. So let's pop onto this. And we're getting the correct DNS information. This is after I've set up DNS. So it did work before when we played with DHCP. So let me ping Bob. Now on our DNS server we've got that in there. So let's just see what happens. So inbound, it should not work. It should be outbound, I'm guessing. So let's pop into simulation mode and see where we're all failing. That one we need to delete that option there. Let's go back over to here. It worked. Just took its time, eh? So let's see how it goes. Capture forward. We're sending a DNS request across our network. All our routing and everything is good. Now we've hit our ACL, and the inbound PDU says the source is 192.168.10, destination 192.168.20.10, and that's come through. Because our ACL is on the inbound, so it's going from this network back in. Let's have a look at our packet. So now our source is 192.168.20.10, so that's our DNS server. The port is 53, so the source port, the equivalent 53. We're using UDP, so all well and good. Yep, I was wrong. You can apply this, and I've got it completely asked about. And then we ping Bob, and off we go, and all good. Now, if we have a look at that ACL, show IP access lists, we've had two matches. So line number 10, permit UDP host equivalent domain is another word, so equivalent port 53, to anywhere that starts with 192.168. Remember there's the implied deny at the end of this. Now in extended it's deny any. So deny from anywhere to anywhere. So it's not just deny any. It's implied in there, it's not seen. So what we should see is that this PC, which is on 192.168.20.31, should not be able to actually get out of our network. So we've still got the ping there for 10.0.0.1 and destination host unreachable. So our ACL on the inbound interface, as close to the source as possible, has permitted DNS server from responding, but denied our PC from actually getting out, or anything else for that matter. The only thing that will actually respond out of this network is DNS. The cute one is, we'll go into simulation mode. I'm not too sure if it's queued or not. Let's just go into this guy over here. Let's ping 192.168.20.31, which is, I think it's this address. Just double check. Do an IP config. So 192.168.20.31. I'm not updating my data because this is obtained an address via DHCP, so putting it in there is a bit of a moot point. Okay, so let's pop back up to that and let's hit enter for that and follow this ping through our network. So we'll capture forward through our VLANs into our router, the routers take over, and the ping comes all the way in, so there's nothing to stop the ping coming in, but it should kill it on the way going out. So it won't support the response. So that'll just sit there and die, and it'll just keep sending information through there, and it'll try it again, and it dies, and it tries again, and it dies. So not the best ACL, it's a fairly limiting one, so again, be careful when you apply your ACLs. A really nice one sometimes is to find the option for established. So let's put in a named ACL just because we can. So IP access list, extended, and the name we're going to give it is ext ACL. Capitals is always a good idea. So a named one. The only difference is we've got IP in the front, where before we just put in back up here, access list 100, and went on our way. Now we've actually got extended ones. So let's permit. We can permit IP, TCP, UDP. So let's just go for IP. Seems a bit daft. So what's source addressed? Well, let's go for any. And our destination could be anything we like. So let's do any. This seems a bit daft and doesn't give us much to play with, so let's hop out of that. TCP any, and the one I'm looking for is this one, which is the established option. So you can't have an established IP, but you can have an established connection with TCP. So when we send off a TCP packet across our network, or rather a segment, beg your pardon, when it comes back, it either comes back with one or two flags set. One is the acknowledgement flag, and the other one is the resend or RST flag. So if one of those flags is set, it's an established connection. So with this named ACL, we're permitting only established connections from anywhere to anywhere, and they still have to have that established option set. So we can apply that to any particular interfaces that we want. So generally it will be an external on router 2. I mean, we've created this ACL on router 3, so we'd have to create it on router 2 according to the 3 Ps rule, and only allow established connections back into our network. So anything that did not initiate on the inside will not be allowed through. So the established option is worth investigating. Back in here, again, other ones that we need to think about. ICMP is one. So our ping is an ICMP protocol, and from anywhere to anywhere, and we've got a couple of extra bits. So are we permitting echoes, echo reply, host unreachable, net unreachable, port unreachable, protocol unreachable, TTL exceeded, or just all unreachables? So if we were to apply this on an outbound going interface, then if we were to ping from this up to here, then the echo reply would come back, and we would have to enable that one then. So echo reply would be something we could do with ICMP. So there it is. So if we show IP access lists, the two we've created both extended ACLs. This one is just permit UDP equivalent to a particular port number. So we've got a far more degree of control over what we're allowing in and out of our networks. In our extended named ACL, and I've only just gone through the process of how we go through and actually create them, we've permitted TCP from anywhere to anywhere, but only established. We've also permitted ICMP from anywhere to anywhere echo reply, but we can certainly add hosts, as we did up there. We can add not just individual networks, but range of networks by putting in a summary filtering system. We can nail our particular ports, use UDP, TCP, ICMP, routing protocols, so EIGRP, some tunneling with GRE in there. So it's quite involved. Well worth playing with. Once you're comfortable with most of your routing and switching and your IPs and your port numbers, then have a play with these, because it does take a while to get them sorted and get them working. So all good. We'll leave that one floating in the breeze there. Run it through. Have it up for you as a share, but that's as far as I'm going with extended ACLs. We need to get some samples to work with, but work slowly with them. They become quite interesting. Okay, thanks for listening. Bye.